So first of all, today we are going to demonstrate how to program on Google Colab. So if you have not get access to Colab, then you can now search Google Collaboratory. That's the full name. And then the first one is the website, research.google.com Collaboratory. So you click open it. So if you have already write some notebook, then it will prompt you. If this is the first time, then it will show what is Collaboratory. Okay, so here I provide you some getting started and also some data science, right? These may be interesting and useful introduction to you. But then today, let me start doing something very, very simple. Just 7 lines of coding can make a text-to-speech application. Okay, so it's so powerful that simply make use of 7 lines of coding will make a text-to-speech application available. So then maybe you can follow me if you are interested. Just Google search, Google Collaboratory, and then the first page looks like this. It does not require any installation. It is an online real-time platform. Then you simply click File. Then you can now create a new notebook. Okay, yeah, this is creating a new notebook. And then it is a very user-friendly platform, so you can name your application. Say, for example, now we are going to do a text-to-speech application. Then let's call it text-to-speech. Then it allows you either to code or to write text. So it depends. If there's a circle with a triangle, that means you are coding. If you would like to add text, then you can type, maybe it's the first trial of using Colab to write Python code, right? And then this is just the text format, anything you like. And then more interestingly must be the coding, right? So let me show you how to code. Right here is what I prepared for all of you. So we make use of a built-in gTTS, I mean Google text-to-speech converter, right? Then making use of this library, then we can produce a text-to-speech coding just by 7 lines of code. So maybe we can do it one by one. So let's see any question first. Can you follow me? Get access to Google Colab and then up to this open or new notebook. Yeah, good. Okay. Then the first line, always install the software. So the standard language is pip, and then install. Now in this example, we install the Google text-to-speech application. Okay. Then click this triangle. We'll run this line of code. Let's run it first. It will take maybe 20 seconds because it is initializing and using the online, collecting the gTTS and downloading, all the required subroutine. Then it mentioned successfully installed gTTS already. Okay, then the second step, as I mentioned, add coding. Just 7 lines will be enough. So now we have this gTTS. We import the gTTS application, and then we need some display. So you simply type accordingly, because now we are using the IPython display application to import is audio, because later on we have to convert text to speech, right? So we need an application which can recognize the text and then convert it into speech. And we need a display to spell out audibly the speech, right? Okay, so in this example, we use the IPython.display and we import its audio function. And the fourth line is what you want to speak. Okay, so you can type anything you like. The function code is gTTS and then open bracket. Any word you type here will be voiced out later with a quotation mark. Say, for example, I type hi, good afternoon, property 384 students, welcome to today's class. Okay, and close quotation mark. This is what I want the system to voice out later on. Then this is the TTS. I store the sentence in text, right? So I need to save it in an audio file. So let's say I simply call it 1.wav, a wave file, okay? Just any name you like, just store it. And then the sound file, I name the sound file as this 1.wav. Then that would be the end. Okay, last line of code would be audio is the function, right? Is the application. Then audio what? Audio of the sound file. I define the sound file as the 1.wav. And 1.wav save the TTS. Then I want it to autoplay. That's it. Okay, just 7 lines of code. So let's try to run it and see what happened. See whether you can hear, right, the gTTS audio. If you can, maybe you can type in the chat box or put a thumbs up.
Hi. Good afternoon, Property 384 students. Welcome to today's class.
Yeah, excellent. Yep. So that's very, very exciting, right? It's so simple and user-friendly. Nothing have to learn. You simply install a Google built-in library called Google Text-to-Speech gTTS application. And then just type what you want to speak. Then it will save in a WAV file, and the audio command can speak it out, right? Maybe I can try another, more interesting one. Make an announcement in audio now. This week, we do not have a quiz, but you have to do the quiz on last week guest speak. Right, then you can listen without looking or reading, right? And what I have made in the announcement. Let me try it again.
This week we do not have a quiz, but you have to do the quiz on last week's guest speech.
Right? Wow, powerful, right? So this is what I mentioned 2 weeks ago. This is not machine learning. This is simply an automation. Because Google built a library called gTTS, which can recognize all English words, right? It looks like a library, it looks like a dictionary. Then all words are included in the dictionary, and it will directly point to how to pronounce them. Then any word you type, provided that those words can be recognized in the dictionary, then it can produce or convert into a pronounceable word. Then it can save in this file, and the audio function can convert it into speech. So it is a kind of automation. So it demonstrates how programmers make programs so easily. And I really would like to emphasize that is a collaboration. The reason why it's called collaboratory is because more programmers, they build library, just like gTTS. Indeed, it requires thousands of millions of lines of code in order to make a gTTS. But once some programmer produce a library, then other people can make use of it. That is a collaboration. So we need people to work together. If you are interested, right, no matter as a full-time or a part-time programmer, then we can share with other programmers on this Colab platform, and then people can tap on each other and work together and produce a better world. Okay, that is the first example. So just see whether you have any difficulties in completing this task. No problem. Good. Okay, then let me continue to the second task. It is even more powerful. So let me open it. I have prepared 3 workshop tasks today. The second task is to forecast stock price. Okay. So of course it's longer, right? And if you do not want to type one by one, then you can go to the module, and I have prepared an article. The article provides all the codes, then you can copy and paste. Okay. But if you would like to type, then you can also follow step by step. Okay. Or maybe I can type step by step so that you can just follow what I would like to demonstrate. Okay, let's open a new notebook. Yeah, then let's call it forecast. And I'm going to use FBProphet, right? FBProphet is a free downloadable software written in Python, and that's why it can be used in Google Colab. So that's the reason why the first code must be installation. Okay, so you can type !pip and install FBProphet. That is the name of the application. Okay, FBProphet, FB, and then PROPHET. So it's a kind of forecasting application. So this demonstration is to use FBProphet to forecast stock price. Okay, and then because we are going to download the past data of a stock, so we need to install. In this case, I use Yahoo Finance. That's called Y Finance. That means we are going to download the past history data, the daily closing price of a stock. So I will demonstrate several different stocks, including, say, Apple, or Hang Seng Index, or New Zealand 50 Index, right? I will show you how easy it is. Simply plug in the code from Yahoo Finance, then it will be able to forecast its future price by FBProphet. Okay, just 2 lines of installation, and then from FBProphet, we import Prophet. Remember, it has to be capital P. Okay, that is the function name. Okay, from FBProphet, we import Prophet. And then from Yahoo Finance, we import Yahoo Finance and then rename it as YF. So that it saves time, right? We can simply type YF in the coming coding. And also we need datetime as, right, datetime. So this is to designate the start date and the end date, right? When you make a forecast, then how long in the past would you like to extract the data? And then, right, probably you must have heard about pandas. That is panel data, because in machine learning, we almost always use panel data. So pandas becomes a very commonly used Python application. So normally we cut it short as PD. And the last one, if you want to plot the graph, then we need some application to visualize graphically. Of course, if you are not interested in plotting graph, then this one is not necessary. But I would demonstrate how to plot graph. So that's why I import the matplotlib library and just call it PLT. Okay, so these are the preparation routine you can follow and run the code. So maybe I stop a little bit, see whether you can follow, and it will show you, right, all the requirements, satisfying it, and then it will tell you, right, the applications are downloaded and also successfully installed. Okay, so let's see whether you can follow so far. Of course, if you write, okay, good. Then the second step is to define, okay, add code. Second step is to define the start date. So let's call it start, and then we use the datetime function and to tell I want to start from, say, 6 years ago. Okay, it's comma. Of course, right, coding requires a lot of formatting, but you can simply follow, right, what have been done by other programmers. So we can try any start date and end date. So today should be October 12th. But of course, if we are using the S&P, right, the US data, then we can up to 11, because in the US, right, they are still the 11th of October. Okay, that's the defining start date and end date. Okay, then in the first example, I use Apple, but of course you can use any other stock. Let me show you how to define the stock name first. So now I define AAPL as the stock of Apple, and I will extract from Yahoo Finance, right? We define YF as Yahoo Finance, and then there's a function called ticker in Yahoo Finance. Then simply make use of double quote, and then this is the specified name by Yahoo Finance of each stock. For Apple in the US S&P, it's called AAPL. AAPL stands for Apple. So I will show you how to find this code. later on. Okay, no worry. You simply follow like the step. Then I will show you later on how to change it. Then we have to tell that we define history as AAPL. That's the stock name, the history from start day and end day. And then just adjust for the holiday. That's it. Let's run this 4 lines. Then it will extract from 2015 to today's Apple stock historical price. Okay, click run. Then nothing happened. How can I know whether it has extract or not? Then it is either I type his, then it will type some of the other. Right? If you simply type the variable name, then it will show 5 lines from 2015 to today. Then you know that, let's say we focus on the closing price, right? And volume. Closing price, it is 142.899 US dollar. And this is the trading volume. Okay? But then, if you would like to present it in a better way, then we have to use pandas. So it depends whether you want to present it in a table or not, but it's very simple, so you can simply follow what I demonstrate here. Right? So in pandas, they usually use data frame. They call DF to define data frame. Data frame, that means put the data in a table. So panda, panel data, then use the function capital D and capital F. Indeed, Google Colab provides some kind of suggestions, right? When you type the command. And then, and put a bracket here. That means we define DF as the data frame now. And so we put the X, that means the date, as the historical record index, and then index. And also we define Y as the historical data, but we choose the closing. You can choose open or close or whatsoever available in Yahoo Finance. As shown in this table, you can show open, high, low, close, or volume, or dividend. Okay, so usually, right, doing forecast, we like to forecast based on each day's closing price, and then dot values, and df dot tail, right? Then here the bracket, if you put empty, then it will print just 5 rows. If you put, say, 20, then it will print 20. Okay, just 4 lines, we'll put the data, historical data in a data frame, and then we extract only the close, that means the closing price, without including others. Okay, so it becomes very neat now. Right, the X and Y, the date and closing price, and the number of records, you will find, the latest one, the closing price on October 8th. Right, that is the way to use Panda and to make the data neat. Okay, now the most interesting part must be to use FBProphet to do the forecasting, right? It may be a little bit complicated. Let me explain step by step. Or if you do not want to understand, you can simply type or copy and paste what have been done by other programmer. then just enjoy the result. Okay, so now we defined the model M. That's the name, right? You like any name you want. We define M using PROPhet function, and then we allow seasonality forecast. Probably you have learned doing forecasting, we need to tell the trend and cycle. And cycle includes seasonality cycle. So here, say for example, we make the most simple forecasting model. That is, it does not include daily seasonality. That means that would be the most simple, right, PROPhet model. And then we fit it, right? We do the best fit on the data frame using the PROPhet model M. And we define future price called future using the model M, and then the command make future data frame. That is the name of the command on PROPhet. It asks how many days of forecast you are going to do. If you want to forecast 1 year, then type 365. And if it is daily frequency, then you have to tell it is a daily frequency. Of course, I'm not good at details. If, say, for example, you're really interested in using Facebook PROPhet, then you can Google search Facebook PROPhet. It will provide all the detailed information. Okay, and then forecast. We define forecast using the model M to predict. Predict is the command, and then predict what? Predict the future. So we want to report it in a table. So we make use of the forecast function, and then report the X, report the Y, and report the lower bound, and report the upper bound. And if you want to show the last 10 rows, then you put type. If you want to report the first, then you put head. Then how many records you want? 20, say for example. Yeah, just 5 lines will make the prediction using PROPhet. Let me show you the result first. Run it. Yeah, wow, so quick. Right now, it can estimate up to 2022. That means 1 year later. Right? And closing price. The forecast would be 198 with a lower bound 184 and upper bound 210. Right? That is a forecasting. And of course, more interestingly is to plot graph, right? We want to plot it in graphical form to make it more visualizable. So then that's the reason why I import matprop. So now it becomes so user-friendly. Simply type m.prop. M is the model name we defined. And then we want to put the forecast. That's it. Yeah. So from 2015, the black line shows the historical data, and the blue shows the upper bound and the lower bound. And then right here, the 365 days shows the forecast. Okay. Yeah. So maybe let's see whether you can follow up to now. So maybe I wait for 1 more minute, see whether you can follow and produce this forecast with the chart so far. Okay, then the last step, I just would like to stop this demonstration of this workshop 2 is to show you the two components, right? As I mentioned, doing forecast is based on the trend and the cycle. So it is so powerful that we can decompose the forecasting components, simply type plot components. Then it will plot the two graphs. One is a trend line and the other is the seasonality or the cycle. So it is very, very user friendly. I think, right? Say, for example, here you will find that since 2019, the trend is going upward, and then every week, right, will show the weekly cycle, and more interestingly, here shows the monthly cycle, and May or from April to June seems to have the lowest price, and then September will have the highest price cycle. Okay, so it is a very user-friendly forecasting tool. So now let me go to Yahoo Finance and tell you how to identify the stock code, and then come back here to estimate other stock price. Okay, then Google search Yahoo Finance, you type, okay. Then in Yahoo Finance, click open Yahoo Finance, then each stock will have a unique code. So maybe let me try Apple first, as I use AAPL, right? Yeah. So AAPL is the unique code for Apple Incorporated. So you simply type the code defined by Yahoo Finance, then, right, that is exactly the price. See, right? It looks like what we have downloaded. And so let's say now we want to port New Zealand stock index 50. So let's see what is the code. It is NZ50. Okay, so later on we will go back to Colab and then just change AAPL by add or power sign, right? The power sign NZ50. Then it will show this, right? Today's price 12994. And then another one is, say for example, how about Hang Seng Index, the Hong Kong stock market index. It is power sign HSI. It is about 25,000. So these are the two examples we want to try it again. Okay, the first routine can be kept the same, right? That is about installation and then import the command. So it does not require any redoing. And then the second routine, it defines the start day and the end day. And now we can define up to today now, right? And simply replace AAPL by New Zealand 50. In the double code, that is the Yahoo Finance code, power sign New Zealand 50. That is the code for the New Zealand. Is it New Zealand 50 or New Zealand X? Let me double click. It's NZ50. Correct. Right. Power NZ50. Now, whenever it's AAPL, we change to NZ50. Rerun it now. Yeah, it shows today's closing is 12994. That's exactly the same, right, as what we found here, right? So it confirmed that we are downloading the correct data, right? And it is today. And then, right, we can rerun the data frame. Now it shows 12994 today. And also we can predict it using Prophet. If everything the same, we simply click the triangle to run the code. It takes seconds. Yeah. So then let's plot it and see what is the forecast. Wow. Here shows you, right, the uncertainty in the coming future. And the reason for the uncertainty is probably because the recent sudden plummet, right, during COVID, and then back to the normal trend. But then let's see whether we can, right, decompose the two components and see any seasonality pattern there. Yeah. So, wow, it shows that April would be the lowest point, and then usually will go upward until the end of the year. Okay, yeah, that is about New Zealand stock market. And then let me also try the Hang Seng Index. Then I simply replace HSI, power side, HSI, and then define it as HSI. Then everything the same, and it shows that, wow, today's closing is 24,800 something point. It's exactly what we found, right, in Yahoo Finance. Then maybe we put it in a data frame with the closing price, and then use Prophet to forecast the price in the coming years. Good. And plot it, right? It's very user-friendly. And this one is more interesting as the cycle seems to be more vivid, and that shows a very strong cyclical forecast. Especially if you decompose the components, then it really tells you very different story, because in the Hang Seng Index, it is the September and October would normally be the lowest point. And indeed, if you take a look about the recent case of Hang Seng Index, it really shows you, right, what happened in the past 2 months. Right, that's exactly that, right? During September and October, right, we got a substantial fall, right, in Hang Seng Index. So I really appreciate this yearly seasonality chart, which tells a very interesting story. Okay, so that's for this second demonstration using FBProphet to forecast stock price, which can be downloaded from Yahoo Finance. Let's see any question first. Oh, good. Okay. Yeah. Then the last demonstration would be, let me show you the W3. Today I prepared 3. This is AVM, because I know that all of you have learned how to use Azure, right, in assignment 2. to produce an AVM, an automated valuation model of house price. So then, but because Azure does not require any coding, it is so user-friendly that you only drag and place, then you can build a machine learning application. So today, I would like to show you how we can program an AVM using Python. So of course, right, it may be a little bit confusing, right, because it requires a lot of installation and coding, but at least it shows you what you have achieved in the assignment tool to build your first AVM by machine learning algorithm. Now I want to show you how can we use Python code to build a simple AVM. Okay, so probably we do not have to retype it because I have already uploaded the article which provide the full detail and explanation line by line of the coding. You can copy and paste into Google Colab platform and you can rerun anytime. So I just would like to go through it and tell you how we program AVM using Google Colab platform. Okay, the first routine again is to install. And because now we are going to use a regression, so we install the scikit-learn. Okay, that's what they call the scikit-learn. Okay, so we run this installation routine, then it will show you right the installation, whether it's successful or not. Then the second routine would be importing all the necessary tools. If you want to plot graph, then we need this again, the matprop library. Okay, then if you want to do regression, then we need Seaborn and also this scikit-learn, and again the panel data, the pandas, and also the number analysis, right, called NumPy. And the most important of the import would be the last two. We import from the sklearn for train test split and also linear regression, right? In Azure, I think you must have learned how to train the system. And because we are going to train the system, then we have to split our data set into training data and test data. So sklearn provide a built-in function to automatically split your data set into test and trained data sets. Okay, and then of course we are going to use linear regression to do this AVM. So we also import from sklearn the linear model for linear regression. So let me run this second routine first. You do not have to put it like me, right? You can run line by line, or you can include everything in one block, right? It's up to you. Then in this case, we need to import data. So in my example, I upload a CSV file. This is my CSV file. That is Auckland housing price 2017 in CSV format. So I upload my house price data, which includes every transaction in 2017 in Auckland, the house's characteristic, including number of bedroom, number of bathroom, 4 areas, and the date of transaction, etc. But then, because it is saved in my Google Drive, then I have to use this application from Google.Colab, import drive, and mount the drive to my content drive. and then read the CSV file. Okay, so it is a very good in security because Google Drive will ask you to input a security code before you can download from your Google Drive. Okay, so say for example, if you run this routine, then it will ask you to click this URL, right, which provides you a security code, just like an authorization code. Then you import the code, copy and paste the code here, then it allows you to download the data file. So I come back here and then Control V, that means paste, and so enter. So that is the authorization code. If it is correct, then now it is running to download my data from my Google Drive and shows the first 20, right? Head mean the first 20 record. So say for example, the first record is a transaction of a house in Auckland with 1 bedroom, 1 bathroom, 23 square meter, freehold land, and transacted in 1990. Okay. Sorry, that is the year built, right? The cohort. It was built in 1990, and then of course you can take a look about the transaction day. So I make it very simple. I only include the number of bedroom, bathroom, building area, freehold or leasehold, and then a year built, and also a month of the transaction date. That is okay. And based on these housing characteristics, right, we use linear regression to estimate the market price, and it built AVM. So here, all pound sign refers to comment. So you do not have to type it. I simply would like to explain what these 3 lines are. So I use a pound sign to explain in text. Okay, so we define X and Y. X is defined as the data of the price. Sorry, I mean X refers to the attributes, right? To say the number of bedrooms, number of bathrooms, and then Y refers to the house price. And we split train X and test X, train Y and test Y into 4 different data group, and make use of sklearn's command, which automatically split the data set into training data set and test data set based on this random method, right? This number you can refer to, say, sklearn, which make use of a randomized process to randomly pick 10% of the data to become the test set, and then the remaining 90% data as the training set. Okay, you can change this parameter, right? You can say put more data for testing mode, then you increase it to say 0.2. That means 20% will become the testing data. Okay, so we run this routine, which defines about X and Y, and also define the test and train data set. Okay, then this is the machine learning part by linear regression. And so we defined, right, LR as the linear regression function, and we feed the X and Y in the training data set, right? So then by means of this training, then we can predict the house price Y by means of the attributes now. Okay, that is the sklearn linear regression function, which make use of the existing transaction information, and then by means of linear regression, it learn how to estimate house price by means of this training set of data. But then it does not show any result. How can we know whether it works or not? So now we have to use pandas again to define the data frame, and also we compare the actual transaction price and the predicted transaction price. Bearing in mind that, right, we have 10% data split into a test data set. Now we can compare, see how well the machine learning algorithms perform by comparing the actual, that's the test data Y, the actual transaction price, compared with the predicted transaction price based on this machine learning algorithm. Okay, so let's see how well it performed. This is what we call the evaluation process. It's not so good, right? Probably because we only provide several hundred number of transactions. Say, for example, here, the actual transacted price is $207,000, but the predicted one is about 302,000, right? And then this 414,000 is predicted to be 399, not so bad. Okay, yeah. And these two seems to be in the correct order of magnitude, right? This is a very expensive house, about 7 digit, and it estimates in a 7-digit price. And similarly, this one in the 6-digit price, it also estimates in a 6-digit price. So not perfect, but not bad. Now we can test whether the AVM can tell the price correctly or not. So I simply use, right, type in the figure. So number of bedroom 2, right, 2 bedroom, 1 bathroom, 78 square meter, freehold land, right, and then year built would be in year 2000. And then let's predict it. So here shows you, right, based on this information, it predicts that this house would be sold in $814,000 something. Okay, then of course, right, you can say plot the scatter plot. So maybe I do not go through it line by line, but then this is to visualize the relationship. I think, right, the most interesting one will be this one, the building area and the house price will have a positive association. And then we can also make use of this heat map, right, to show the correlation coefficient and see, wow, building area and price will have a positive and strong association at about 74%. And also, right, the last one would show the actual and the predicted one, even though it's not perfectly on the 45-degree line, but at least it depicts a positive association, indicating that, right, the regression algorithm is predicting more or less accurately in the testing data set. Okay, so that's what I have prepared today, right? 3 demonstration. The first one is a very simple one, an automation text to speech algorithm. And then the second one is using FBProphet to do the forecasting, and the third one is AVM. So I hope, right, you would appreciate using Python coding and like to use Google Colab platform. It is very user friendly, and then you can start, right, doing some simple coding if you like, or at least you will appreciate programmers' work in the coming future, and we can work together right? Based on this kind of collaboration, then people, they can work together to build machine learning code together. That would be a very good platform for us, right, to build our startup. Yeah, okay, thank you very much. So that's all for today.